Every steel motorcycle kickstart lever begins not with metal, but with earth. The foundation of the entire production line relies on this specialized foundry sand. Mixed with binders and moisture, the coarse aggregate transforms into a stable material, capable of withstanding extreme thermal shock. Packed tightly around the master patterns, the dense sand holds a perfect negative impression of the future levers. Removing these metallic templates requires a delicate touch. Even a millimeter of shifted sand would ruin the final casting. The two halves, known as the cope and drag, are meticulously inspected for loose debris. Any remaining dust could create fatal voids or inclusions in the solidifying steel. Once cleared, the heavy steel boxes are locked together. This frame provides the necessary clamping force to contain the immense hydrostatic pressure of the incoming liquid metal. The sealed cavity now waits to be filled. The intense heat has baked the sand into a brittle shell around the newly formed steel. As the molds are violently shattered, the crude cast pieces are finally exposed to the air. At this stage, the metal is technically solid, but still structurally vulnerable. The cooling rate must be carefully managed to prevent internal stresses from warping the long lever arms. Workers hammer away the gating system, the network of temporary channels that delivered the molten steel into the void. What remains is a raw, unfinished plank. It has the correct silhouette, but none of the required mechanical precision. Casting achieves the general geometry, but moving parts require exact tolerances. The rough steel blanks transition into the machining gauntlet. First, a heavy-duty drill press bores the primary mounting points. High-speed steel drill bits slice through the cast iron, removing material bit by bit to establish a true center line. This perfectly round hole serves as the strict reference point for every subsequent operation on the lathe. The lathe operator secures the next structural component inside a heavy, multi-jaw chuck. Strict clamping alignment is critical here. If the steel piece sits even a fraction of a millimeter off axis, the resulting eccentric rotation will shatter the cutting tool. Continuous drilling generates immense friction, threatening to overheat both the high-speed tool and the workpiece. A constant mist of cutting fluid floods the contact zone, rapidly dissipating the heat while flushing away the abrasive metal chips. Down the line, a heavy hydraulic press reshapes the connecting joints. Operating with dozens of tons of downward force, the steel ram forces the cold metal to yield, stamping sharp internal splines directly into the mounting hole. This cold-forming process actively work-hardens the steel grain structure, significantly increasing the shear strength of the final mating surface. Meanwhile, the main kickstart shafts meet the lathe. As the heavy spindle rotates at high velocity, a stationary carbide insert peels away the rough cast exterior in long, continuous ribbons. The aggressive cutting pass brings the shaft down to its final dimensional tolerance, leaving a smooth, unified, geometric surface ready for protective treatment. Every machine cycle refines the raw blank into a viable mechanical part. Despite the extensive precision machining, the bare steel remains covered in residual casting scale, lingering cutting fluids, and microscopic burrs. To solve this, batches of parts are loaded into an enclosed industrial shot blasting chamber. Inside the dark drum, an impeller hurls thousands of tiny steel abrasives at high velocity against the tumbling components. This relentless kinetic bombardment aggressively scours the surface, physically erasing the dark oxidation and leaving a uniform, matte finish. This distinct texture provides the perfect mechanical tooth for subsequent protective coatings to grip. Next, the physically cleaned levers undergo a series of active chemical baths. Submersion in these caustic liquid solutions strips away any remaining organic contaminants and temporarily passivates the reactive bare steel. Without this specialized chemical stripping, invisible oils would cause the final rust-proofing treatments to blister and flake away under physical stress. The raw metal is finally fully stabilized. The heavy industrial processing concludes, making way for manual assembly. Workers sort the newly unified steel arms, preparing them to meet their secondary materials. Sacks of molded vulcanized rubber foot pegs are staged alongside the metal components, ready for final integration. The vulcanized rubber grips are sized with an intentional interference fit. By striking them with a wooden mallet, the technicians drive the tight sleeves over the steel shafts without marring the final surface finish. Friction alone locks the components permanently together. At the final station, a manual arbor press seats the heavy retaining rings. This simple machine provides a massive mechanical advantage. It allows the operator to generate hundreds of pounds of localized force, snapping the steel clips securely into their retaining grooves. Nothing leaves this bench unchecked. From a pile of loose sand to a fully functional mechanical assembly, every station added one irreversible step. The completed motorcycle kickstart lever is the sum of 100 small precisions. Tomorrow, the factory fires up and does it all again.